get started with this. And what we are going to look at is the fourth exercise sheet for our revision, which is on mixtures and averages. Now, to my mind, if you look at the mixtures questions, it typically takes a little longer time to solve these questions in the paper. But trust me on this, that there's not much that you need to know in order to solve these questions as far as the concept piece is concerned. For example, if I look at an algebra question, suppose I look at a logarithm question. The problem with the logarithm question is, one, you need to know the identities very clearly. Second, you need to know how to manipulate a given expression into something that is more convenient for you to solve. All of those things requires a bit more skills in terms of practice and knowing concepts. But when it comes to mixtures, averages, ratios, to a great extent, time, speed, and distance also, what you need to know is just the basic formula. That's all. There's nothing more that you really need to know in order to solve the question. Yes, I do concede to the fact that it takes a little more time to solve that particular question. So, for example, if an average question, if a question typically takes about 2.5 minutes, 3 minutes in the paper to get solved, a mixtures and solution might take a 3.5 minutes for you to solve. A time, speed, and distance might 3.5 minutes for you to solve. But to my mind, it's a fair time you can give to that particular question instead of attempting some difficult question from some topic, right? So please be patient with these topics. Do not expect them to get over in 45 seconds, because it typically requires a narration of a scenario to you, and that narration of a scenario in itself is going to take, let's say, a 35 40 words for the examiner, or 50 words, or a 70 words for them to explain you the scenario. By the time you read it, it's going to take a little time for you to solve. Clear? So I hope all of you have gone through the recorded videos that I had sent it to you on the community group, and those are the two videos where I've explained you the basic concept also. So the problem with such a session is that when you're looking at revision, you can't really revise the complete thing with concepts and all that. So for that, I've shared you those two videos. I hope you've gone through those two videos. Also, I've got questions which are really good questions solve for this particular topic. Couple it with the questions I've given you in today's exercise sheet, 8 more questions. I think that's more than enough for you to revise the topic of averages and mixtures and solution. Okay. So the basic concept of average says what? The basic concept of average says that um, it is equal distribution that you are looking at. Sum of all observations divided by the number of observations is called as the average. But underline the word equal distribution. That's something that I want to carry as a concept during the paper. Mixtures and solutions, surplus and deficit is what I've explained in those two videos. But surplus and deficit, I've come across several students who have come back and told me that is not required. And I concede to the fact that that is not required on several questions. But you will also have to concede to me about a few set of questions which you cannot solve if you don't use surplus and deficit approach. But I can guarantee something, that every single question you can actually solve it with the help of surplus and deficit approach. That is why on almost every question I end up taking surplus and deficit. You can come back and say that there are alternate ways of doing a particular question, and I concede to it that there are of course alternate ways of solving a particular set of questions. Okay, in this classroom I will try to take multiple approaches and solve a particular question. Take whichever way you wish to look at a. Okay, so on that note, let's get started. I hope all of you have solved the exercise. So that's your first question. That's primarily based on averages that we are looking at. Okay, take a minute, try and just solve this, and we move on. Not a difficult one. All of you have given me the correct answer. Let's quickly move on. In a company, 20% of employees work in manufacturing department. Now, before I look at this particular question, I also wanted to comment on something, that these ratios questions, these averages questions, a lot of time your life can become a lot easier if you take the right set of numbers to represent a particular variable. If you do that, it makes your life a bit more easier in comparison to anything else. Is it necessary that you take that? No, it is not necessary that you have to take those kind of numbers and those numbers only. You can take any variable, but being a bit more intelligent will help you do the questions a little more faster. That's all. Right. So let's have a look at this. In a company, 20% of employees work in a manufacturing department. In the manufacturing department, so 80% of the employees are working in a non-manufacturing department. If the total salary obtained by all the manufacturing employees is one-sixth the total salary obtained by all the employees in the company. Okay, so suppose I say that the total salary by all the employees in the company is Y, then if I look at the manufacturing employees, non-manufacturing employees, one-sixth of the total salary is going to the manufacturing employees, correct? That means the non-manufacturing employees will be taking five-sixths of the total salary, right? 20% of the total employees. So let's say I take the total employees as X, then 20% of the total employees will be 0.2x, and this is going to be 0.8x as your non-manufacturing employees. Okay. Now, then the ratio of the average salary obtained by manufacturing employees, average salary by manufacturing employees will be what? The total of salary obtained by manufacturing employees divided by the total number of employees, which is 0.2x in this case, is to the the average salary obtained by non-manufacturing employees. Average salary obtained by non-manufacturing employees will be what? Five-sixths of y divided by 0.8x. That's it. You have to just take the ratio. X and y as the variables will get cancelled out. 1 by 6. So the 6 and 6 will also get cancelled out. 0.2 and 0.8 will make it 4. The easy ratio turns out to be 4 is to 5. You should not take too much of a time after this particular step in try to solve it. Try to make yourself better at solving that. This is not a very difficult question. It's a straightforward, easy question, and that's what my point is, that most of these questions are not very difficult. You just got to read them properly and a, a some amount of time at least. You can't expect it to get over in 10 seconds. That's not going to happen. Okay. So any doubts on this? Quick 10 seconds before we move on. Again, salary, when they say one-sixth. So you could have started by taking 6y as the total salary, then this becomes y and this becomes a 5y. That's the only thing, right? So do those particular set of things and you will find your calculations becomes a bit more easier. That's all. Nothing else. Let's move on. Try question number 2. Take your time. Slightly more lengthy question in terms of calculations. Take your time out. All of you have given me the correct answers. Those of you have given me the answers. All of you have given me correct answers. Again, I found a lot of students leaving such a question because when they read the question, they're not able to make sense out of the question, or they find the question to be too lengthy. I would suggest you that these are straightforward questions where you don't really have to apply your mind in terms of framing the equation. It is just that solving the equation is the only part which is left over, right? So you should not be leaving a question because solving the equations is turning out to be a challenge, right? As long as concept is a challenge, I don't know a concept, then you can leave that question. I'm fine with that. But just leaving a question because the equation is becoming tricky is not a good idea, because then solving the equation you are getting a short +3. So let's have a look at this. Three classes X, Y, Z. Take a science test. The average score of X of class X is 79. So average is 79. Let's say the number of students, let's say the average is 79, and let's say that the average number of students in the class is turning out to be equal to X. Can we rely on Calci for particular questions? For these particular questions, yes, Animesh, of course. Beyond a certain, I would want you to use your calculator. I don't want you to use your calculator to do calculation like 32 plus 45. Don't do it on calculator. But if something like this particular question is there on the paper, you must definitely use your calculators. So average is 79, and let's say that the number of students in the class is X. Now the average score class Y is turning out to be 72. So the number of students is Y, and the average score is turning out to be 72, and that of Z is 81. The average score of all the students in class X and Y together is turning out to be 75. So if I look at the score of these class X and Y together, that's going to be 79X plus 79, 72Y. That's the total score of X and Y together. And they've given that the X and Y average is also 75. So can I then say 75 times of X plus Y should give me an equation where I can find X in terms of Y? Absolutely fair equation you can develop from here. This will become 4X and this will become equals to 3Y. So my X turns out to be in terms of Y, and X becomes 3 by 4 times of Y. That's the first thing that I can generate from the first equation that I'm able to form. The average score of students in the class Y is turning out to be 77. So what is the total score of Y and Z? 72Y plus 81Z is the score from this particular set of data. And they are telling you Y plus Z, the average score is 77. So you can again write this equals to 77 times of Y plus of Z. Correct. If you solve this equation, you are going to get 5y on one side and you are going to get a 4z on the other side. So also is something that you can develop in terms of y, which is 5 by 4y. This is something that you can generate. So now your y, sorry, x is available in terms of y, x is available in terms of y, z is also available in terms of y. So these are the two equations that you have got available with you, and y you can keep it in terms of y. So you have every variable in terms of y available with you. What is the average score of all three classes? Now understand what is the total score of all three classes. 79x plus 72y plus 81z is the total score of all three classes divided by x plus y plus z is what they want you to. X plus y plus z is what they want you to calculate. Now x is available in terms of y. You can simply write this as 79 times of 3 by 4y, 3 by 4y. Y, let us keep it in terms of y, and z you can keep it in terms of y once again. 81 times of 5 by 4y is what you will get, divided by x plus y plus z. So x is turning out to be 0.75y. So you can simply write instead of x 0.75, y let it be there, and z is equals to 1.25y. Solving this and using your calculators is not a problem. Y as a variable, you can cancel it out. If you solve this particular value, you are going to get a 77.5. I am not spending time in showing you the calculations because at the end of the day, you will have to do your multiplications and division. There's nothing else that I can help you on this particular piece. Any doubts till this? Let me know, else we move on. Absolutely fair, Rishika. You can do it using your allegations approach as well. Can we use mixtures? Yes, Rajni, that's correct. So sir, can a logic be applied with the options? Tilak, I'm not a big fan of solving the questions with option, to be very honest. Somebody had asked me this question earlier also before even I started this particular class, that for question number 2 we can use options. Yes, you can use options. I'm absolutely fine with that. But I'm not, for some reason, not very convinced that students can solve the question with the help of options, because I typically see experts doing it because they've been doing it for several years. So if you want me to look at the options and try to say that which one can be a good option as your answer, I can probably make that comment because I've taken classes for a very, very long time. Right. But to expect a student in 7, 8 months to master this art of looking at the options, I would want to reserve my comment on that. And I would want to say, rather, I would want to say also that, you should not try questions from options until unless there's no other way out for you to solve that question. Is the only one within 79 and 72 and 81. That's why I said, sir. They're like, yes, that's fair. I get your point. But imagine you can have the options like 74, 75, 76, 77.5. Then what do we do? Rest of the three options are impossible. Yes, Animesh, I get the point. I concede to the points, guys. Whatever you have said is absolutely correct. Tilak, I get that point. Try question number three. Take your time. Okay. Now I've got a few of you telling me option A as the answer, and a few of you have told me option B as the answer. Nobody else has given me anything else apart from this. So 4 by 17 and 3 by 17 is the set of answers that I've gotten at the moment in the classroom. I understand that this is a question coming from the CAT 2014 paper. Now I've got option C also as the answer, which is 6 by 19. Let's have a look at this. An empty metal container, very clearly, and D also as an answer that I'm now getting. So I've gotten all the answers available on the screen at the moment. Let's pay attention to this. An empty metal container without its handle weighs 15% of what it weighs when completely filled with a particular liquid. Okay. So when you, an empty metal container without handle. Okay. So this is empty and without handle also. It weighs what? That weighs 15% of the weight when it weighs when completely filled with a particular liquid, still without the handle. So liquid, full liquid without handle, no handle over here. Okay. If that value is x, then this value turns out to be 0.15x. That's what the question is saying. After adding the handle, the weight fully filled container increases by 5%. Weight of the fully filled container increases by 5% when when you have added the handle to this. So if you look at just the handle, what is going to happen? The when it was filled without the handle, it was x. So filled with the handle, it has become 1.05x. Correct? Now 1.05x would imply what? 0.05x is actually nothing but the weight of the handle if x is the weight of liquid with no handle. Now, these are some of these variables that you'll have to play around with in this particular question. If the weight of the partly filled container is 1/3 of the completely filled container with the handle attached, remember, with the handle attached is what they're talking about. The weight of the partly filled container is 1/3 of the completely filled container with the handle. Completely filled container with the handle will turn out to be what? 1.05x, because x is the liquid with no handle and 0.05x will be the weight of the handle. Together it will become 1.05x, and 1/3 of that is going to be 0.35x. This is what the weight of this particular container is with the handle. Correct? Then what fraction of the container is utilized is what the question is. Now look at this. 0.15 is what? Empty without handle. So the weight of the jar itself. So remove that weight of the jar from here, which is 0.15x. That's going to be what? That's going to give you 0.2x, right? Now remove the weight of this handle also, because you are only trying to figure out what fraction of the container has been utilized, correct? If you remove that also, minus of 0.05x, you are going to get 0.15x as the weight of the liquid alone. And what is the weight of the liquid with the handle you are turning out to be 1.05x. So 0.15x is the weight, and this is with the handle x that you are talking about. And remove the handle from there, you are going to get sorry, liquid x minus of 0.15x is what you are going to do, which is removing the weight of the container from this. So the weight of the liquid will turn out to be 0.85x. So this is without the handle, but with the liquid along with the container. Minus 0.15x, which is the weight of the container alone, is going to give you the weight of the liquid alone, which is 0.85x. So 0.15x divided by 0.85x, x will get cancelled out. This will become 15 by 85 is what you are looking at, which is 5 by, sorry, 3 by 17 is what you are looking at. So 3 by 17, option B becomes the answer. So why are we not including the weight of the metal container while increasing the whole weight by 5%? Uh, Aryan Raj, please understand, X is what? Liquid, no handle, along with the container. This is along with the container, the weight is X. Weight of the container with the liquid in it without the handle is X. Now only a handle has been added, so it increases by 5%. So that becomes 1.05x. And that is why the handle alone is 0.05x. Guys, the sir, could you please repeat that subtraction? Acha, I hope I didn't read the handle attached. They're too smart with the options. Yes, Aryan, that is going to be the case with the actual paper, and this is the question coming from CAT 2014 paper. So you can understand there's nothing that I have changed on this question. Subtraction part, please explain the subtraction part. Please explain the last part. Fair enough, Shriram. Rishika, I'm explaining the last part. So understand this thing that 0.35x, what we are looking at is the weight of this one third along with the handle and the liquid that they have filled in this. So from this, I'm removing the weight of the container alone. So if you remove the container alone, it is going to be 0.2x with what? With the handle on it. What is the handle? 0.5x. So 0.05x. So remove that also. It becomes the weight of only the liquid which is there in this. Now look at this value x. This value x is what? Liquid plus the container and no handle. Liquid plus the container, correct? Liquid plus the container is x. Remove the container, 0.15x. So what are we left with? 0.85x. This is only the liquid, right? So liquid in the final situation when the weight was one third of the overall weight divided by the weight of the liquid that it can contain, which is 0.85x. So 15 by 85 is going to give you 3 by 17. Is this attempt or leave type of question? Definitely attempt type of question, Animesh. I don't want you to leave this question. This is just your concentration level, that how well can you read the question. That's all. There's nothing more there. And I would not want you to leave such a question on the paper, because when you read the question, you will realize there's nothing that you don't know about this question. There's every part of the question that you know of. That's all. You tell me which part of the question is not very clear. You tell me which part of the question requires a formula for you. This is how you judge a question when you read a question. Your judgment has to improve when you are reading the question. Look at every part of it. If there is one part of the question that you are not able to make sense out of, leave that question. I'm fine with it. But when you are able to make sense out of every single part of the question, why would you leave that question? Any doubts, anyone? I hope this is clear. Okay, let's try question number 4. Take your time. All right, so let's get started with this particular question. And this particular question might end up taking a longer time. And this is one of those questions that I'm talking about. That if you look at your surplus and deficit approach on such a question, it helps you solve this question. Sir, I use the surplus and deficit, but it was slightly too lengthy as you get two equations and then solve the quadratic equation. Is there a shorter method for this one? So that's absolutely correct. And this is precisely what I was coming down to, that this question will take a longer time for you to solve. There is nothing else that you can do on this question, to my mind. You can of course say, sir, can I use the options and go backward and all of that, but that again is going to take a lot of time for you to solve. Surplus and deficit approach will give you equations which are solvable, to my mind, and it is going to take time for you to solve the equation. There's no doubt about it. There's nothing else that you can do. Why did I put this question over here? Because I want you to have a feel as to how the cat paper previously has been. There have been some of those questions which are difficult to solve, but once again, once you draw the equation, you will understand that it is solvable. It is not that you cannot really solve it. So let's move on and look at this particular question, and then we'll discuss more if required. It took me 12 minutes. Is it too much? Yes, Shubham, I think 12 minutes is a little more than what is required, but I get the point that this is not going to be an easy, solvable, shorter question. It is not a short question. Let's have a look at this. A percentage volume of milk in the three solutions A, B, and C form a geometric progression in that order. Okay. So now the first, second, and the third solution is in the ratio 2 is to 3 is to 4. When you take the first solution and second solution and the third solution in the ratio 2 is to 3 is to 4, suppose A is the concentration percentage I'm talking about. So this becomes what? AR, and this becomes AR square. This becomes AR square, right? We obtain a solution which has got 32% milk in it. This has got 32% milk in it. When you take the same three solutions in the ratio 3 is to 2 is to 1, then the solution percentage turns out to be 22%. What is the percentage of milk in the solution A is what the question is. Okay. Now let's try to look at the surplus and deficit approach. If any one of you, or rather all of you, I expect you to have seen that particular seen those two sessions that I've given you. 32 is the percentage that you get after you have mixed the three, correct? So I'm going to write an equation over on the screen, and I hope it makes sense to all of you. I'm going to say 32 minus A, multiply that value by the proportion in which the first one was taken, which is 2, plus of 32 minus 3 into, sorry, this should be 32 minus A. Just give me a second. This should be 32 minus of AR multiplied by 3 plus 32 multiplied by 32 minus of AR square. Multiply that value by 4, and that value should be equals to 0. You can develop an equation in terms of A and R from there. So if you look at this, this is going to be 64. I'm keeping the constants on one side. 3 into 2 is 6, 3 into 3 is 9. So again, a 96 that I'm getting over here, and 4 into this. So that's going to be 128, which is equals to 2A plus of 3AR plus of 4AR square. This is what you will get. Now take your value of A common from here. You are going to get 2 plus 3R plus 4R square, which is going to be equals to what? 9, 12, 21, 27, 27, 28, and 288 is what you get over here. This is one equation you get from using the first one, which is 32. Clear? Now you can use the second one also, which is 22%, and draw a very similar equation. So let's quickly try and do this. 22 minus of A multiplied by 3 in this case, plus 22 minus of AR multiplied by 2 plus of 22 minus of AR square multiplied by 1 should be equals to 0. If you do this and solve it, it is going to be 66 plus of 44 plus of 22 is equals to 3A plus 2AR plus of AR square. Correct? Now, if you go further, it is going to be what? 132. Absolutely correct. You get 132 times of, you can take A common over here, 3 plus 2R plus AR square is what you are going to get. Now these are the two equations that you get, which is what I was talking about. Now if you take your first equation and divide that equation by the second one, you are going to realize that a will get cancelled out and you will have an easiest equation available with you in terms of r. You will have to solve it for the value of r, put it back over here, get the value of a. That is all what you are supposed to do. Now if you divide the two equations, only r square, sir, in the equation number 2. Okay, fair enough. Sorry, a was taken common, right? So if you now take the first equation and divide it by the second equation, you will get 132 in the denominator. A will get cancelled out, so I'm just writing 2 plus 3r plus of 4r square in the numerator, and in the denominator what you are going to get is 3 plus 2r plus of r square over there. That's all, right? Now if you solve this, now this gets cancelled at the moment with 4 3s are 12, 33, 4 sevens are 28 and 72. So this will get cancelled with a 3 also. 3 twos are 6 and 3 fours are 12. 24 by 11 is what you are getting over here. Let us just solve this equation. 24 into 3 is 72 that you are looking at, plus of 48r, plus of 48r, plus of 24r square, if I am not wrong. Just give me a second. Sorry. 24r square, and post that what you are getting is 22, which should be equals to, let me just write it over here, which should be equals to 22 plus of 33r plus of 44r square, plus of 44r square. Now you got to solve these two equations and get the value of r from there. That's all. There's nothing else that we can do about this particular question. So let me take everything on one side, and this is going to be 20r square minus of 15r, and minus of 50 is equals to 0. Everything is divisible by 5. So 4r square minus of 3r minus of 10 is going to be equals to 0. You can simply say 4r square minus of 8r minus of 8r plus of 5r minus of 10 is equals to 0. You can take 4r common, you will get r minus of 2 plus of 5r minus of 2 again. That becomes 4r plus of 5 into r minus of 2 is equals to 0. R will be either equals to 2 or r will be equals to 5 by 4 negative of this. Now negative value of r is not acceptable, so my value of r will be equals to 2. If your value of r is equals to 2, you can simply put it over here and get the values as your answer. So 132 becomes equals to a times of 3 plus 2r is going to make it, r was 2, so it is going to make it 4 over here, and r square is again 4. 4 plus 4, 8 plus 3, 11. 132 by 11 is equals to the value of a. A will become equals to 12, and that becomes your answer, which is option B. Sir, after getting the equations in the simplest form, can we use the options for getting the answers? Rn, the problem is option is giving you the value of a. So if you put the value of a as 6, now the problem is that 6 will anyways get cancelled out. So you will still have to solve it for the value of r and then retrace the value. Had the options been for the value of r, you can probably put it over there. But again, that's a challenge on this question. I hope that makes sense. Sit back at home, try that out. You will realize that that's not easy to do, even going by the options on this particular question. Once again, now you would want to ask me that, sir, should I leave this question on the paper or should I attempt this question? I think this should have been not solved on the paper. I found this question easy when working out by this method. Only calculation took a bit of time. Yes, Kumarapan, that's precisely what it is. That conceptually this makes it easy. Calculation wise, you will have to do it by any method that you got. So I did this in the ratio method and got the same answer. Is that okay? Taslima, that's correct. There is no problem. Try question number 5, everyone. Take your time. Okay, all of you've given me the correct answers as of now. There's no wrong answers on this question until this point. Nobody has given me a wrong answer. Now understand this thing: a question coming from ZAT 2015 paper. All of us are aware that the questions coming on the ZAT papers are slightly more tricky and slightly more challenging. Now, on this particular question, I would show you another approach because I've been over and over again being told by the students that you can take alternate approaches. I will show you an alternate approach on this particular question where you can use numbers, but learn again at one point in time you would require to apply your mind to choose better set of numbers. If you choose better set of numbers, you will be able to solve the question by that approach also. And I don't really have a problem with any approach, provided you are able to solve most of the questions using that approach and are able to do it in a fairly short time. That's the only submission that I have for all of you to make. There's no specific method that I want you to definitely use on every question. All of that is not there. Okay, so let's start with question number 5. Look at this. Product M is produced by mixing the two chemicals, chemical X and chemical Y, in the ratio of 5:4. So you are making the product M and you are mixing what kind of products? You are mixing two products. One product is X and another product is Y. And you are taking them in the ratio of 5:4. So I'm taking 5 parts of this and I'm taking 4 parts of this at the moment. Okay. Now chemical X is being prepared by mixing the two raw materials A and B in the ratio of 1:3. A and B have been mixed to make X in the ratio what? In the ratio 1:3. So A has been taken as 1 part and B has been taken as 3 parts. Chemical Y is prepared by mixing the two raw materials B and C in the ratio of 2:1. Chemical Y is prepared by mixing 2 in the ratio of B and C in the ratio of 2:1. So 2 parts of this and 1 part of this is what they're talking about, right? Then the final mixture is prepared by mixing 864 units of M. So you are taking 864 units of M. How many units? You are taking 864 units of M with water. Find the concentration of raw material B in the final mixture is 50%. If the concentration of raw material in the final mixture is 50%, then how much water has been added to the product M? So you have taken 864 units of the product M and you have added water to this in such a way that the final mixture contains only 50% of the material B in it, right? How much of the water was added to the product M? That is what the question is. Now, as I said that I'm going to talk about choosing the numbers on this particular question and trying to do the question. Okay. So if I look at how many parts over here, I look at 4 parts over here, 3 parts of B and 1 part of A. So if I take 5 over here, 5 liters, then the problem is I'll have to find out the value of B, I'll have to do 3/4 of 5. Instead of doing that, I will take that and take the value of X, quantity of X in a multiple of 4, correct? But X and Y are mixed in the ratio of 5:4. Keep that also on your mind. B has been taken 2 and 1 over here. So taking Y over here as a multiple of 3 makes a lot of sense, because then this will turn out, then each of these values will turn out to be in integers, right? So over here, I'm looking at a multiple of 4. Over here, I'm looking at a multiple of 3. So at this level, I'm looking at the multiples of 12, right? So let me multiply this by 12 and let me multiply this by 12. It will end up giving me the values of A, B, and C at each of these levels as only integers. So I'm taking 60 liters of X and I'm mixing it with 48 liters of Y. That gives me a total of what? That gives me a total of 108 liters, correct? Of M. Now understand this thing: 108 liters of M is what you are getting over here, but you wanted to get 864 liters of M, correct? So 864, 100 into what becomes 864? 100 into 8 becomes 864, right? So 60 into 8 and 48 into 8 will give you this values, right? So at every level you can multiply it by 8 and you can get the values of A, B, and C ultimately, right? Now look at this. If you take 60 into 8 liters of X and 40 into 48 into 8 liters of Y, you can get the value of A. So how much is the value of A available? Let's have a look at this. 1/4 of 60 into 8. In this 864 liters is what I'm counting. So 4 twos are 8, 120 liters of A is available with us, or 120 units of A is available with us. Now look at the value of B from the solution X, or from the quantity X, which is going to be what? 3/4 of 60 into 8. If you take 3/4 of 60 into 8, that's going to be 120 into 3, which is going to be 360. If you take the value of B from here, it is going to be 2/3 of 48 into 8. If you do this, then this is going to be 3 6 are 18, 32. 32 into 8 is what you are looking at. 8 5 are 8 2s are 16 and 8 3s are 24. 256 units of B is coming from Y and 360 units is coming from X. Now you can calculate the value of C, but that is not required. If you look at the values of B alone, it's going to be what? 6 1 and 6. 616 units of B is there, and this is 50 percentage of the total quantity. So the total quantity should turn out to be 1232, right? If it is total quantity of 1232, M was taken as 864. So subtract that 864 from here to get a 368 ultimately, and that becomes your answer option B. Why have I subtracted this? Because the total quantity should be 1232 by our logic of B being 616. Double of that should be the total quantity. 1232 should become the total quantity. From there, subtract 864, that was M. So what will you be left with? Quantity of water. So you should have mixed 368 units. So how did I get the 12 parts? Please understand this thing, Nikhil, that this was 4 units and this was 3 units. So I made it what? 12 units. Why 12 units? Because 12 is a multiple of 4 and 3. Sir, could we also use surplus and deficit? Yes, Siddharth, absolutely. Specific to this question, why did I not do surplus and deficit? Honestly speaking, when I solved it, I used surplus and deficit. Students ask me always that can we avoid surplus and deficit and do it using the numbers. That is why I wanted to do one question on the screen with numbers, and that is why what I've done on this question. But you can definitely use surplus and deficit to get the answer right. You will definitely get the right answer. There is absolutely no problem. Any further doubts, anyone on this? But trust me on this, guys, that these numbers are not easy to take. Again, you will have to apply your mind to take the better numbers. That's all. If you don't take better numbers, what is going to happen is your calculation is going to look tedious. That's all. If you want your calculation to look easier, you will have to choose the better numbers. Otherwise, you can always say, sir, I'll take 5 liters of this, 4 liters of this in individual liters. I'll calculate. All of that is possible. There's absolutely not a problem. Let's try question number 6. Very quick, very quickly, we'll try to finish this. Not a difficult question, very regular question. All of you've given me the correct answers. Let me quickly solve this particular question. Again, to my mind, not a very difficult question. If you've gone through the first 2 videos, you will find this is pretty easy for you to solve. A vessel contains 500 liters of milk. 50 liters of milk is taken out. So you start with 500 liters of milk and 50 liters of milk was taken out and 50 liters of water was replaced. 50 liters of water was added to this. Of course, now you will have 500 liters of solution in it rather than just the milk. Okay. Now from this 100 liters was removed and 100 liters of water was added again to this. Once again, now you have a 500 liters of solution available with you. And from this 150 liters has been removed and 150 liters of water has been added to this. It becomes once again 500 ml, 500 liters. Okay. Now find the ratio of milk and water in the resultant mixture. That's all what the question is. So now understand 50 is what fraction of 500? 50 is 1/10 of 500, correct? So 1/10 has been removed. That means if you start with calculating the quantity of milk, you will realize 9/10 will be left over at this level. Why? Because only water was added, so it will not change the quantity of milk after the removal. Post this, you remove 100 liters. So 100 is what fraction of 500? 1/5. So 4/5 is what you will be left with. And at the end, you are removing 150 out of 500. So that is what fraction removed? 3 by 10 as a fraction removed. So you'll be left with 7 by 10. This will be the quantity of milk left over. Divide this value by 500. You will get the ratio of milk and water finally. So 500 will get cancelled out. You will be left with 9 into 4 into 7 divided by 10 into 5 into 10. That's what it will be. So 2 5s are 10 and 2 5s are 10. 5 into 5 into 5. You are left with 9 7s are 63. Have I gone wrong somewhere? 9 by 10 is going to be 0.9 into 0.8 into 0.7 divided by 500. That's milk to total. Milk to water has been asked. Absolutely fair. So if you just, fair enough. Okay. So if I look at this, this is the quantity of milk that you are talking about. 500 minus milk is going to be water. Absolutely fair. My bad. That's milk to total. It should be divided by the amount of water. Absolutely correct. Thanks, guys. Just give me a second. Yeah. That's the quantity of milk that you are talking about. Water will be nothing but 500 minus milk is what 500 minus milk is going to give you the quantity of water. This is the quantity of milk that you are talking about. This is the quantity of milk that you are talking about. So 500 will still stay there. I will have to change this. So sorry to create this mess. 500. Okay, that's the quantity of milk that you are looking at. It is again 5 10 and it is going to give you 500. So this will also get cancelled out. 9 into 4 into 7 is the quantity that you are left with. So 7 fours are 28. 9 into 28 is what you are looking at. So you're going to get 248 liters of milk over there. And if you look at water, that's going to be the leftover, which is 252. 252 liters of milk will be water will be available over there, and milk to water is what you are looking at. So you're looking at 248 is to 252, and if you solve this, that is going to be 63 is to 62. 9 5 is 49. 252, sorry, this should be 252 and this should be 248. So this is going to be 252 is to 248. That's going to be 63 is to 62. Option A is the correct answer. So sorry to have created this mess, guys. It happens. Clear? No, Ranit, it is 63 is to 62. The ratio of milk to water has been the question, and I had calculated by mistake over here as 248. 252 is the correct answer over here. Milk will be 252 and 248 will be water. The correct answer is 63 is to 62 and not none of these. Try question number 7. Take your time. Taslima, just check your answer. There's an error there. Okay, let's have a look at this. There are two mixtures containing tin, nickel, and lead. So there are two mixtures that you are looking at. Each of these mixtures is containing tin, nickel, and lead in it. The first mixture contains 30% lead, and the second mixture contains 26% nickel in it. The percentage of tin in both the mixtures is same. So the percentage of tin in both the mixtures is turning out to be same. If 250 kgs of the first mixture is mixed with 350 kgs of the second one, then the percentage of tin in the resultant mixture is 30%. Now understand, they've in the first place told you tin is same, and on the second place they are telling you that what, finally tin is turning out to be 30%. If you take the two mixtures which each has got tin as 30% and you create a mixture, the mixture will also have tin at 30% only, right? So if they say the other way around, that the final mixture has got 30% tin in it and both the ingredients had same percentage of tin in it, then what is going to happen? That value is going to be 30% only. So this is 30% and this is also 30% in it, right? So if you look at this 30 and 30 60, it should be 40% nickel in it, and this is going to be what, this is 56, so 44% of lead must be there in it. Find the quantity of lead in the resultant mixture. Lead is going to be what, zero point 0.3 times of 250 plus 0.44 times of 350 in it. If you solve this, you will realize it is 229. Option B is the correct answer. I hope we are clear with this. The point over here is, if you do not understand that the final value of 10%, which is 30%, has to be the values of 10 in each of these, then solving this question will become very, very difficult. It will become almost impossible for you to solve this question if you don't understand that particular clue. Two things you will have to combine to get down to that clue. One you need to understand is that the final mixture will have the same percentage as that of the two ingredients, because they've mentioned this, that they are equal. Percentage of tin composition. Other one, please understand this thing, that did you understand this part, that the percentage of tin in both the mixtures are same? Just say yes if you have understood this. And now understand, the final mixture contains, then the percentage of tin in the resultant mixture is also 30%. Is this also clear? Now understand this thing, that if the two ingredients have equal percentage of tin in it, then the final percentage will all of 10 will be same as these two values, which are same again. So if the final is 30, then these two have to be 30. Does this make sense, Advan? Yes, Kumarapan, that's correct. That has to be there, no? Sir, why are we taking 250? Don't we need to add 350? Taslima, that you will do only if you are calculating the final percentage of lead in it and then trying to solve that question. You can't do it initially from there. So doesn't the mixture ratio affect the final percentage? Gayatri, understand this thing. No, it will not. It will not. Why? Because they are equal, right? So if you take 10 kg and if you take 20 kg, this 10 kg has also got 30% on it. This 20 kg has also got 30% on it. Then the final will also be 30% only, no? This percentage will change depending upon these percentages and not on these quantities. Does this make sense, Gayatri? Try it. One last question for the day. Animesh is saying something that I want to uh, read it out loud. Sir, every question was doable, but time was the issue in most of them. Animesh, that is how I expect the cat paper to be. That time is going to be the issue. So choose your right question, invest that 40 minutes at the right time. You don't have to solve all the questions anyways. Solve sufficient number of questions and come out of the paper. You will be fine. You will get a very good percentile. Absolutely not a problem. But if you end up choosing a wrong question and spend that time on that wrong question, then there is a problem. So choice of the question is very, very critical when it comes to the cat paper. Understand one more thing, guys, that tomorrow's session is a critical reasoning session. We have made it a 50 days to cat session, but that is primarily not a 50 days to CAT session, because that's a very intense session. So those of you who are not our classroom students and listening to me at this moment, please ensure you attend the session live. The recordings of that will not be made available on the YouTube channel later on. Critical reasoning is a very, very important session. Please attend it. Those of you who are our students, please ensure that you also attend it live, because that's where the fun of critical reasoning will be. Otherwise, you will miss out on the part of it. So can you solve the question 100 liters of pure, 30 liters removed? Example where equal amount is not replaced. Soumya, I'll talk about that after this particular question. Two vessels A and B of equal volume contain wine and water in the ratio of 4:1 and 2:1 to their brims. 2 liters of the solution from A and 3 liters of solution from the vessel B are poured into the big vessel C. So 2 liters from the solution A and 3 liters from the solution B. Let me take mixture for this particular question, the surplus and deficit approach that I'm talking about. So let me take 4 by 5 as the strength of wine over here, and let me take 2/3 as the strength of wine over here, and I'm mixing the two and pouring this in the vessel C. Suppose I'm getting the strength over here, final strength of this total of 5 liters being X. So x minus 4 by 5, why? Because 4 by 5 is greater than 2 by 3. So x minus 4 by 5 into 2 is equals to x, sorry, it should be 4 by 5 minus of x. It should be 4 by 5 minus of x into 2 should be equals to x minus of 2/3 of 3. Just solve this. This is going to be what? 8 by 5 minus 2x is equals to 3x minus of 2. Solve this further, you are going to get 5x is equals to 8 by 5 plus of 2. That gives me what? 18 by 5 as 5x, and the value of x is 18 by 25. So your strength of wine in the 5 liters of solution, turns out to be 18 by 25. Now, if the solution C is 20% of the capacity of C, now understand 5 liters is turning out to be 20%, correct? That means the total capacity must be 25, 100% will turn out to be 25. So 25 is the total capacity of the can. That is something that we have figured out by using this particular information. What proportion of volume of the vessel C should be the volume of water that shall be added, so that the ratio of wine and water in the vessel becomes 1:1. Right now you have 18 by 25 as the strength of wine, and you are taking 5 liters of this. Let me take y liters of water to this. What will be the strength of wine in pure water? 0. What is the final strength of wine that you want? That is half, correct? So what equation will we make? 18 by 25 minus of half into 5. That should be equals to half minus 0 into y. Y will give you the quantity that we are talking about, correct? Let's just try and solve this. This is 50 as the LCM, so that is going to be 25. This is going to be 36, so that's going to be 14 by 50 into 5. That should be equals to half of y. That's going to be 25 and 5 over here. So 14 by 5 is the value of y. You actually need the answer as y by that should be 25, and this should be 36. So this should be 11 over here and not 14. My bad, guys. 11. So y should be what? 11 by 25. The value of y is 11 by 5 over here, and you need the answer as y by 25. So it is 11 by 5 divided by 25 is what you are looking at. So it is 11 by 125 as the proportion in which you should be adding water. The quantity of water was y, and they're asking you proportion of the volume of C. So volume of C was 25. So y by 25 is what they're asking you. The value of y you got as 11 by 5, and y by 25 is going to be 11 by 125. So answer option C should be the correct answer. I hope all of us are clear with this. Right Now, Soumya, the question that you are asking, when they're removing 30 liters and adding 40 liters, it is just going to complicate the question, and it is not going to make any difference to these answers that we are doing, except at all these steps where you will have to change your calculations a lot. That's all. So I will try to answer this question by taking a very simple example, but I still feel that those kind of questions we have not really seen on the cat paper, and not even on the mock papers and all of that, because that's just a calculation that they want you to do. So what let me just discuss this out, what Soumya is really asking me. I'll try to answer that question, and then we will wind up the session. Just give me a second, let me find some space. Can you explain why by 25 thing? Acha, please understand, the last question they were asking you what, they were not asking you the quantity of water added, they were asking you water as a proportion of total capacity of the container C. We found out the total capacity of the container C was 25. So what proportion of that? Y by 25 of that. So Y was not the answer. Y by 25 was the answer. Why we were getting 11 by 5. So Y by 25 was 11 by 125. Got it? Fair. Now, what Soumya had asked me was, let's say if you start with 100 liters of milk and you remove, let's say 20 liters, but you add only 15 liters of water, correct? And then you have 100 liters of solution to this. And suppose you now remove 10 liters and you add 5 liters of water to this. And then over here in this 100 liters, or this will not be 100 liters. So over here, what will happen is it will become 95, and over here this will become 90. Got it? So now I hope, Soumya, this is precisely what you were talking about, that not taking the equal quantities, correct? So if you start with 100 and you are removing 20 liters, that means 20% is removed. You are now getting 0.8. Now understand, when you have added 15 liters of water to this, the total quantity has become what? 95 liters. But in 95 liters, this is the quantity of milk, correct? Now, out of 95, you are removing 10. So your percentage removal will become 10 by 95 into 100. Got it? So, or as a fraction, if you want to look, you are going to say 10 by 95 is what you are removing. So you are going to remove 2 by 19. So you will be left with 17 by 19 of the value. So you are now going to take 17 by 19 of this. This will be the quantity of milk left over after the removal of 10 liters. Adding water does not change the quantity of milk. So in this 90 liters, this will be the quantity of milk. So this percentage now that you are going to take is not going to be out of the same base that you were originally taking. That percentage value and the base for that percentage calculation will change. That's all. I hope that answers your problem. Great. So that brings me to the end of this session, guys. Those of you are not a part of the 50 days to CAT program, you can reach out to us at 9282442221. So that brings me to the closure, guys. I have just one question that I'll take.